Permutations and Combinations. Okay, you say, well, what does that mean? Well, let's read. An arrangement in which the order is important is called a permutation, not a perm. You're not curling your hair now.
That's not curly.
Okay?
Right.
Okay, so, well, for me, it would curl my hair. Alright? And then curl yours, wouldn't it? Alright. So an arrangement in which the order is important is called a permutation. An arrangement or listing where the order is not important is called a combination. Okay? Working with these arrangements, you'll use the word factorial. The symbol for factorial is this exclamation point. Okay, that means factorial. Or 5 factorial, which means 5 times 4 times 3 times 2 times 1. So the number 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1. That's something we're going to need to use today. It's going to be huge. The expression n factorial means the product of all counting numbers beginning with n. So you can put in for n like 10 or something. You're counting backwards to 1. The definite, now this is really important. The definition of 0 factorial is what? Is 1. Make sure you know that. Okay? So, let's read this. You don't have to write it, let's just read it. The symbol P, 7, and 3, this means the number of permutations of 7 listings taken 3 at a time. Okay? So you start at the first number. So you start at 7 and you go 3 numbers down. This is 1. Then what's next? 6. And then what's next? 5. So I started at the first one and I take 3 of them. 1, 2, and 3. So now if I multiply 7 times 6 times 5, which is 210, that gives me P73. Now let me give you an example. 4 factorial is the same thing as 4 times 3 times 2 times 1. In other words, when they just give you 4 factorial, you go from that number all the way to 1, right? Right? Now the difference is, with something like this, P73, it's telling you where you start and where you stop. You see that? So if I've got P of 12, 2, okay? I start at 12 and I take 2 of them, 12 and 11, the next one down. So I got 12 times 11, and that'll be my answer, whatever 12 times 11 is. So you start here, you take this many terms. Okay? It's saying the permutation 12, 2. Now, the symbol C73 means the number of combinations. So P means permutations, C means combinations, okay? Now, it's going to be a little bit different when they put a C. You don't do it the same where it's 7 3 times, okay? To find C73, divide the probability of 7 3 by 3 factorial. So you do this, and you divide it by this, okay? So you do the probability of the permutation of 7 3, and you divide it by 3 factorial. Why did I choose 3 factorial? Because it's this number, 3. You see that? Whatever number is second, when it's a combination, you put it on the bottom factorial. Okay? So I'm going to do 7 times 6 times 5 divided by 3 times 2 times 1. So let's write it out. This means 7 3 times, the third one down, so 7 times 6 times 5, and I'm going to divide that by 3 times 2 times 1. 3 times 2 times 1. You see that? So if they give you a combination, you do the permutation on top, and then on bottom you take the second term and factorial it. So 7 times 6 times 5 is 210 over 3 times 2 times 1 is 6. How many times does 6 go into 210?
140 times.
So 210 divided by 6 equals 35. So the way you want to write your answer here is you want to say the combination 7, 3 equals 35. So here they want us to find the permutation 5, 3. So we start at 5 and we go 3 down. 5 times 4 times 3. So I started at 5 and I went 3 of them. 1, 2, 3. 5 times 4 is 20 times 3 equals 60. So the permutation 5, 3 equals 60. Combination 5, 3 is the permutation 5, 3 over, so it's going to be the permutation 5, 3 over what? 3 factorial. Remember, the second term factorial goes on the bottom. So when you're doing a combination, you put the permutation on top and the factorial on bottom. We said the permutation 5, 3 was 60. You divide that by 3 factorial, which is the same as 3 times 2 times 1, which is 6. 60 divided by 6 equals 10. So now this third example wants us to tell, is it a permutation or a combination? We talked about earlier, a permutation has to be in order. Combination, it doesn't matter what order it's in. Okay? So, it says Fred plans to buy 4 tropical fish from a pet shop. Does it matter what fish you buy, first or second or third? No. So this is a combination. We're going to write this as a combination. Okay? Because it doesn't matter what order he purchases the fish in. Relation represents a permutation or combination. If I have a stack of 18 tests and I'm going to grade them, it doesn't matter which order it's in. So this is a what? Combination. 2 flavors of ice cream out of 31. Remember, if you just take a small amount of a big group, then the order doesn't matter, so it's a combination. Here I got first, second, third place winner. That matters. What order? So this is a permutation. Here I've got 20 students in a single file line. Let's imagine at the lunch line. Well, the order matters. Or let's say you're in the line for a ticket. Okay, and they only got 19 tickets and you're number 20. You're not going to get one. So the order matters, didn't it?
But they don't talk about that.
They don't, but I know. So this is going to be a permutation. Arrange each word by the letters. Okay? Which means this is a permutation because the order does matter, right? Since it's a permutation, remember use the permutation. Now, here we've got the word range. Let me show you a short word and you help me. Let's say we have the word set. S-E-T. That's one way we could do it. We could do E-S-T and we could do E-T-S. Right? Then we could start with the T or the S and say S-S-T-E. Now another way we could do it is to start with the T and say T-S-E and T-E-S. So how many different ways could I order the word set? 6 different ways, right? So you just take, how many letters are there in the word set? 3, and you do that factorial. What's 3 factorial? 3 times 2 times 1, which is what? 6. And how many ways do we say we could do it? 6. So if you just take how many letters there are and do that factorial, that's how many ways you can arrange the word. Can I arrange the word range? I've got 1, 2, 3, 4, 5 letters, so it's going to be 5 factorial, which is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So how many ways can I arrange the word range? 120 ways. That seems like a bunch of ways, huh? I could arrange that. Okay, the next one's quartile. There's 1, 2, 3, 4, 5, 6, 7, 8 in it. So it's going to be 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What is it in your calculator? 40,320. So you can see that's a bunch of ways, isn't it, to arrange that. I can't imagine having to list them all. Okay. What about median? There's 1, 2, 3, 4, 5, 6 letters, which is 6. 6 factorial, which is what? 720. So you can see 2 factorial equals what? What's 2 factorial? 2. What's 3 factorial? That's 6. What's 4 factorial? Well, 24. Okay, 5 factorial is what? 120. And then 6 factorial is what? 720. So you can see that it increases quickly. It goes from 2 to 6 to 24 to 120, and now all of a sudden it's 720. It increases extremely fast, right? And then we'll do one combination, and then I'll let you start on your homework. This is permutation starting at 5 factorial, going 2 places. So I go 5 times 4, and that equals what? So the permutation 5, 2 equals 20. Now we're going to do the combination 12, 3. Okay, remember when it's a combination, you do the permutation of what it says, 12, 3, and you put it over the second number factorial, 3 factorial. Okay, so now you got 12 times 11 times 10 divided by 3 times 2 is 6. So 12 times 11 times 10, what is that?
1,320.
1,320. And divided by 6, what does it equal?
20.
So the combination 12, 3 equals 220. Alright, the last thing for the day is you need to know how to multiply 5 factorial times 2 factorial and divide it by 3 factorial. Now you're thinking 5 times 4 times 3 times 2 times 1 times 2 times 1 divided by 3 times 2 times 1. That's a lot of work. Okay, let me show you something. If I've got 5 factorial, that's 5 times 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. And I'm dividing it by 3 times 2 times 1. 3 times 2 times 1. Let's just imagine that's a 1 right there, okay? Now, if you got it on the top and the bottom that matches, you can cancel it. These 3's cancel, these 2's cancel, these 1's cancel. So the answer is just going to be 5 times 4 times 2 times 1 and you're done. 5 times 4 is 20, times 2 is 60, times 1 is 60. So what does all this equal? It just equals 60. So all I did was cancel.
It's 40.
5 times...
40.
Oh yeah, you're right, it's 40. 5 times 2 is 20, times 2 is 40, you're right. So all I did was I canceled these 3's, these 2's, and these 1's. So let me show you an even easier way to do it. If I've got 5 factorial and I know 3 factorials on bottom, I'm going to say it's 5 times 4 times 3 times 2 times 1. What's another way to write 3 times 2 times 1?
3 factorial.
3 factorial. So I'm going to say 5 times 4 times 3 factorial times 2 times 1. Okay? And what am I dividing by? 3 factorial. So now do you see that 3 factorial and 3 factorial cancel? And I'm still going to get the same answer. 5 times 4 times 2 is still 40.
Oh, okay.
But I want you to see that you don't have to do all on the top and all on the bottom and then divide. Okay, so let's see if there's another one here. So let's try this one. Try this one with me. You got to see what cancels now. You see 8 factorial and 7 factorial on bottom. So you know 8 factorial is 8 times 7 factorial, isn't it? Am I right? And then 4 factorial is 4 times 3 factorial. Okay, and then on bottom I divide by 7 factorial and 3 factorial. Now you might be saying, how did I know to stop at 7 factorial and to stop at 3 factorial? You want to try to stop at whatever's on the bottom. You see how there's 7 factorial on top and bottom now? What can I do?
8 times 4.
Cancel them. Cancel them. So the whole thing is just 8 times 4, which is what? 32. So you see how fast that was? Rather than doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1 divided by all that. You understand what I'm doing?
Today we learned how to solve permutations and combinations.
Good.